with the...
Hello, hello, hello. See? Hello? Okay. Hello, everyone. Thank you for being here on one of the early talks of this KCD Swiss Romand. Today, we're going to tell you how we have been working the last few years and how we have changed drastically our way of deploying the mobile data core. And because, as you know, some traditional telco companies still, they are deploying their network in a very manual way using old tools. And that's why we have gone from weeks to seconds. And in this presentation, we're going to tell you how we have achieved that. So to start, I will introduce a simple analogy. As you can see here in the left part of the screen, we can see a traditional paper map. It's very overwhelming. It contains a lot of data, but it makes its point, right? You can see where to go. You can see the final destination. That's what we call the desired state. And then in the right part of the screen, we see a modern navigation map. It's the same, right? We can see, again, our final destination, but in this case, we have some live data. We can also have the estimated time of arrival. We can have proposed routes, and many more things. And that's what we call GitOps with KRM. So now we have more dynamic changes, and we have now schema validation and automation. My name is Pablo Garcia. I'm a DevOps engineer, and also I'm here with Fabian Schulz, also DevOps engineer, working in the same team for Swisscom. As you know, Swisscom is one of the major telco providers in Switzerland, but also an IT provider. And now we are now transitioning from a telco company to a more tech company, let's say. And this process, we call it telco to techco. Just to kick off with the presentation, I will briefly explain what's the mobile data core. As you might not be familiar with these terms, it's very simple. I'm pretty sure all of you here, you have a mobile device or a laptop, even IoT devices. So this network, this user equipment, user device, is going to try to find the nearest antenna to connect to the internet. This antenna belongs to the radio access network. And it will send the data to the backend, the mobile data core, which I will explain briefly in the next slide. And the mobile data core will be the responsible to route all the traffic to the end destination. In this case, it can be in the internet, intranet, whatever. So if we zoom in into the mobile data core, what's the mobile data core? So as you can see, all these blue boxes, each of these blue boxes is a network function. A network function is somehow defined to do only one responsibility. So we have multiple network functions doing multiple responsibilities, communicating between each other. And they can do things like authenticating you. They can also assign you the speed you have contracted with your telco company. They can assign you an IP address. They can forward you the traffic in the end to the end destination. To enter in more details, why this is complex? This is complex because, first of all, I will start introducing what's each blue object. As I said, every CF, every NF and every network function is a containerized network function, which means that they are containerized. We put them into containers, and we deploy them via Helm. Configuration is done also using Helm values, and we use a protocol to push this configuration to each container via a protocol called netconf. I'm not sure if you're familiar with it, but basically netconf is going to put a big XML file containing a lot of parameters into each container, and every container will know what to do with the configuration, just in a brief way. And then we have the problem of scalability. A dev environment contains around 2,000 pods, and also, as I told you before, we have a lot of interdependent configuration parameters that I will show you now. So this is how the configuration of the whole mobile data core looks like. We cannot even see it. I cannot even see it. But if we zoom in, we can see that there is IP addresses, DNS records, VLAN IDs, subnets, many more things. So just to summarize, we have seen now 3 problems. First one is configuration. We have a lot of thousands of parameters that need to be in sync in the mobile data core network. We have the problem of scalability. Now in Swisscom and in Switzerland, we have 4 data centers, so we need to have somehow redundancy to provide high availability. And last but not least, we are in a closed ecosystem. What does this mean? Now there are like 2 major vendors in the telco world, let's say, providing this mobile data core. And the problem is that they are not really cloud native in the sense of we don't have open source code, there is not a lot of documentation, and it's really difficult to deal with that. So now I will hand over to my colleague Fabian, which will introduce you what's our solution to this problem of deploying the mobile data core.
All right. Hello, do you hear me? Yeah. So I'll show you now the Swisscom approach on how we solve this and what our automation does. So to start with, I reversed the order. So first of all, we now try to go with open source technologies and use the whole CNCF ecosystem. Using GitOps and Kubernetes operators, we try to solve the scalability issue. And the configuration is now intent-driven. So before it wasn't intent-driven. Before people were crafting this large file that you saw before. And now the idea is to have a more intent-driven automation. You will see what this means in the following slides. I have a very broad, simplified overview of how this looks like. So our model is this layered Kubernetes operators approach. So you start with a high-level intent. You will see an example later. This high-level intent is then read by the first-level operator, which will then understand what needs to be done. It has a business logic coded in, and it will use some second-level operators, which will do more of the automation, and then there will be third-level operators. Now, what's really important here, what is really nice, is that the user will only look at this high-level intent, and all below is basically automated. So the idea is to not have, for example, IP addresses should not be in the high-level intent. We should not care about IP addresses, like we don't need to know what they exactly are. The automation takes care of it. And how we do this, I'll show you in the next slides. All right, so what do we need to have connectivity? So on the left, you can see the radio access network. On the right, you can see the mobile data core. So first, we need IP addresses. So the mobile data core needs IP addresses. We then need the transport configuration. So there's probably routers and switches on the way, so we need to configure them. And then we need to configure the workload. So the actual core needs to be configured. All right, so what do we need if I want to list it down? So first, we need IPAM. We need prefixes and IP address management system. For this, we use NetBox. So NetBox uses IPAM. It's an open source tool. Then we need routing. So for routing, we use on one side MetalLB. And then we also have a network as a service. So we have an internal network as a service, which is basically an API we can use. And that programs then the whole, in the backend, all the switches and the routers. And then we need the configuration. So for the configuration, we use SDC. So this is for schema-driven configuration. It's a new open source tool developed by Nokia, and which we also co-develop with them, which then also pushes the configuration using netconf to our CNFs. All right, so let's get a bit more technical, and let's see how this looks like in practice. Do I have to have a pointer? No. Maybe here. All right. So in the middle, you can see this is our management cluster. So we have a management Kubernetes cluster. On the right top, you can see there is our application cluster. So we have our workload in there. And on the right bottom, you can see the infrastructure, so the routers. So we start with a first high-level intent. So this is a Kubernetes resource. It's of kind network. You define some parameters. Here, parent prefix, prefix length, just so it will know, the operators will know where to get the IPs from. Maybe you have some parameters for the tenant or router parameters. This is then read by the first operator. It's our config assembly operator, we call it. And this one then knows, OK, for a network, I need prefixes and IP addresses. So it generates the claims. These claims are then read by the Netbox operator. So this is now our second level operator. And this one cares about claiming and getting the IPs. So you can see here that we have this nice separation, that the Netbox, the lower level operators, they have their field of knowledge. And this one only cares about IPs, doesn't care where the IPs are from. It just knows that we need IPs or prefixes. And then the Netbox operator will call Netbox. It will get the IPs and the prefixes. And then you will have these CRs. So these are all CRs. So there's prefix CRs, IP address claim CRs. And so once they are there, the config assembly operator sees, OK, we have the IPs and the prefixes, so I can continue. What do we need next? Next, we need to configure the routers. So it creates a new CR, which is our router configuration. This one is then read by our network as a service operator. So basically, this is also a Kubernetes operator which reads the parameters, and then calls our backend API to configure the routers. Once this is ready, the config assembly operator will continue. It will generate the CRs for BGP peering and IP address pools. These will then be copied over into the workload cluster. And there we have MetalLB, which will do the peering. So here you can see how we set this up. So now we have the peering, the connectivity between the application and the routers. And now I'll pass over to Pablo for the demo to show this in action.
Thank you. OK, let me just zoom a bit more. All right. So let's start with the demo. I will show you, first of all, our cluster to show you how the operators look like. In this case, I have a plain kind cluster. Can you see it? Yeah, OK. So we have, I just created a kind cluster the other day, and I just installed our 3 operators that Fabian was telling about. First one is the config assembly operator, this spot running here. Then we have also the Netbox operator, which is going to be the responsible of contacting the Netbox API to provision all the IP addresses and the prefix. And then finally, we have this network as a service operator that we call Thor. Okay, we call it Thor because it's an in-house system to configure the whole network. And then we can also see some boxes, which are basically the Netbox backend that I also deployed in my cluster. So let's start with the first step. The first step is I want to get a network. So I define the high-level intent, as Fabian was saying. This is of kind CCD primary network topology, and we have here some parameters, as Fabian was saying. We have the IPv4 enable. As an example, we select this tenant, and then we also select this configuration for the platform, and also some parameters for the MetalLB part. So this is the network that we want to provision. And now, if we simply apply this CR into our clusters, is where the magic will happen in question of seconds. So now, I will just go to this terminal. In the first part of the screen, we'll see the CCD primary network topology CR, okay? The CR I just showed you. And then in the second screen, I will basically show you all the, let's say, sub-resources, sub-custom resources created. All the IP addresses, the prefixes, the claims, and the MetalLB parts. So let's start. It's going to be quite quick because it really takes a few seconds to deploy it, but yes, I will try to be as fast as I can. So if I just do kubectl apply, and I select the network. Oh, sorry, wrong path. We can see here that the network is being created. We have different columns to track the status. For example, we can see the IPAM is already ready, which means true because all the sub resources have been already provisioned. And then we have the connection point. Connection point, as I told you, is our abstraction to basically configure the network. Connection point just defines how the network is set up. It takes also a few seconds because it's now connecting to the Swisscom, to a stack in Swisscom dev stack, just to try this. And these are also the MetalLB resources that have been created. Now, as you can see, this state just changed to true because all our sub-resources have been already created. It took us nearly 40 seconds to provision a network. So here we can see, as I told you, the prefix claim with this prefix. It says also that the prefix has been assigned. We have also the different IP address claims with the IP addresses. As you can see, we have the P1, the P2, and the virtual ones. Wait a second, I cannot. Yeah, and here we have also the MetalLB. Sorry, this is the connection point, which is, as I told you, the one which is configuring the network. And we can see here the BGP peers, which are the MetalLB resources to do the BGP peer between our applications and the routers. So as you can see, it took seconds, and now I can just basically show you what are some of the benefits of the Kubernetes operators that I'm pretty sure you are familiar with, but just to showcase them here. For example, now what I'm going to do is just delete the connection point, for example. Connection point, I think it's this one. And we can see here that it's pending to delete. This will take a few seconds because, as I told you, it's contacting the API. Because of the automation, it has some delay. And thanks to our, let's say, reconciliation, because we said, OK, we want a network, our operators is going to bring back again up the connection point because we want to have this high availability, let's say. So if something is deleted in our source of truth, it will keep like that. But if we manually delete it, we can see, for example, that now it has been recreated as soon as it got deleted. So now, again, it's in pending state. And as soon as it gets created, it will just be ready again. And one of the other things interesting that I can show you here is what we call garbage collection. So we group resources and we make them live together or be deleted together. And if I delete the whole primary network, we can see that as soon as I press enter, everything will just be deleted in question of seconds. So our operators are doing a great job, and they are basically deleting the network. This, again, will take a few seconds until the connection point will be just deleted. I think it just got pending state because it didn't complete before. But yeah, in question of seconds, everything gets deleted, and we don't have any primary network. So just to summarize again, let me just go back here. This is what Fabian said. So just to summarize, we have this high-level intent, and our config assembly operator is gonna read the high-level intent, create the sub custom resources. It's gonna all these IPAM resources are gonna be reconciled by our Netbox operator. Our Netbox as a service operator is gonna also reconcile the connection point, and the MetalLB resources are also gonna be created. So now, again, Fabian, I think you can just conclude a bit with the rest of the presentation.
Yeah, so I hope with this we wanted to show you just a glimpse of our automation. So one part, which is maybe is a bit more relatable because there's IP addresses and not just internal things. So let me click. No, it doesn't click. Sorry, I'm trying to get this. All right. So what did we achieve? So now we have a KRM-based solution. So we have input and output can be modeled as Kubernetes resources. We have garbage collection, as you saw. So of course, it's not just deleted in the cluster, what Pablo showed. When he deletes it, it's also in the backend. Everything gets cleaned up. So especially IP addresses are already always scarce, so you want them to be cleaned up. We have output flexibility. So you saw that we have various different backends. So some backends are Netbox, which is our IPAM. Some backends are our connectivity as a service offering. So you can have different backends connected together. We have the constant reconciliation. So we had one example where it was really nice. They just wanted to rename things. They renamed it at the top level, and everything renamed itself. And they were like, otherwise this takes lots of time and is very error prone. So this is very nice. You have ability to define helper functions. So the thing is with the, you'll see more afterwards in the summary, but the Kubernetes operators really help us to define specific, to really, like, we're very flexible. We can do whatever we want with the operators. So this is very handy, and we have gradual adoption. So what is nice about this layered approach is that our customers usually, when I say customers, it's the internal users in Swisscom, they can start to use the lower level operators. So for example, they start to just use the IP management. And if they feel confident with it, they will start to use our higher level ones until they've gained more and more confidence in our operators and then use the full automation. So what were the benefits that we gained through this? So on the left side, I'll show you how it was before, or let's say how it's still done nowadays, and what the solution we present should go live beginning of next year. Is that first you have the low-level design with the IP addresses. It's done in Excel, so this took days. Now, let's say we estimate it takes 2 hours to create those high-level intents. The next step was to do the reservations. This also took days, and now you saw it's a matter of seconds. Then, of course, it's configuring the routers, do the change requests. This is now also automated. This is a matter of minutes. So this is, for example, the connection point that took some time. So this maybe takes a few minutes for all the backend systems to be updated. And then, of course, is also all the testing. I mean, now we also use all the CNCF tools to do the testing. So I think this is really, I mean, it's more our also internal marketing slide. We can show that the automation actually is worth it, that they invest money in it. All right, now maybe you have some questions about why not just use Helm, Customize, Argo, Flux. So we think those have a bit limited dynamic assembly, so it's you have limited capabilities. You don't have any custom functions, and they're only partially Kubernetes based. So that's why we use the operators. I think now there's some newer alternatives. So usually we gave this talk once before, and the question was like, why don't you use Crossplane? Well, Crossplane, we looked at all the different things that were out there 2 years ago. It was Crossplane v1. For us, the capabilities were not what we needed, so that's why we use custom operators. Now there's Crossplane 2, so maybe that changes a bit things, but for us, the idea is that the Crossplane, if you don't use public cloud, if you have backends, you need to integrate yourself. You can develop plugins, but if it's like your own systems, it doesn't. For me, there's no added value in creating those plugins if it's not public, if it's not for the public cloud, if other people cannot use it. So there, I think you have more flexibility by using your own operators, and since you need to put the work anyways to create the plugins. And then there's KRO. I think KRO is a very nice tool. For us, it was still too early stage 2 years ago. I think now it could take some of the higher level operators, could be replaced with KRO. So just this engine to create actually the Kubernetes resources. But this was not ready, and it's still, I think, in a very early stage now. But I think this is a tool to look out for. Now, to sum up a bit, I want to, we have been, our team, developing Kubernetes operators for the past 1-2 years and providing them to internal teams. So I want to share with you some of our learnings specific to this. So first, some avoids. So of course, avoid checking in low-level configuration in Git. So IP addresses, VLAN IDs, we don't want them in Git, we just want them in the cluster. Don't build an all-in-one operator. So I think even those little operators we build, they get quite complex because you need to think about all the different states you can have, the deletion when you edit things, so they can get complex quite fast. And also because of the gradual adoption. Don't neglect industry relevance. So the KRM challenges and solutions are not unique to your sector. So we are telco, but I'm sure lots of other people do this. Other sectors have similar problems and probably also similar solutions. Then some aim to, so leverage abstraction. So of course, you saw our high-level intent. The idea is that to your customers, you only show them what they actually need. So you start with a small intent, and then they will come asking, hey, can we have this feature? And then maybe you add it if it's needed, but try to really leverage to have a simple interface. Reuse cloud-native tools, of course, like TestCube, Cert Manager, Argo, all the Kubernetes-based things. And also upskill your users. So for us, it was very important that we have workshops also with the people using it, so they understand what it means, this intent-driven automation. It's not like before where they had workflows which generate this config file once and then nothing moves. So I think this has some implications, so it's important that they understand it. And of course, add monitoring early. Not everyone, of course, can use the command line as good, or the K9S, and knows all those tools. So here's, for example, one of the dashboards we have, and you can directly see all the networks, the prefix, the IPs, and you have the list of, I just put some names you don't see, but you can see that all the networks are ready. So I think this is also very nice, and of course, this is also a nice marketing slide to showcase what you automated, so showing some numbers is always nice. Then maybe one last slide, a bit more technical. Maybe some of you develop Kubernetes operators. We suggest to use frameworks. So we use KubeBuilder. I think that was very good. I mean, I think there's lots of other ones now, also different programming language, not just Golang. But yeah, there's no need to start from scratch. Really leverage status conditions and events. So this really helped us in the end, because then you can use tools like kubestate metrics and directly export everything in Grafana. So it's very nice if you have exactly the state and also the events, so you can have a look at the CRs and really see what happened one after the other. And I mean, one little Golang tip, it's like we really like defer. I don't know if you know the defer thing. So basically, you register a function which gets executed no matter where you exit your parent function. So in a reconciler, this really makes sense, because you have this long reconcile loop where you iterate through all the conditions, and if something is ready, you continue. If something is not ready, you exit. And the idea is that on every exit, you want to set the different status conditions and events. And for us, like the defer function helped us to just have a nicer, a cleaner code, because it exits always using that function. Also, one thing was probably add kill switches. So we have an operator. We have an operator running. We have different customers, with the customers segregated in namespaces. And it happened to us that the customer comes like, hey, stop the automation. We have an issue. And then we're like, well, OK, so we scaled down the operators. That worked. But of course, then it's also stopped for the other customers. So add some kill switches. I think this is our next step that we want to do. For example, namespaces, so you can pause the automation, because sometimes, yeah, there's always scenarios where they want this to stop. And then last and not least is always, I mean, contribute to the ecosystem. We are trying to push this also. So for example, here you have the Netbox Operator. So this was fully developed by our team. You can see it's in the Netbox community space. There's a bit of naming clash with Netbox Operator, so they have multiple ones, but they also have a Netbox Operator, which is just some AI agent, which does other things. This is the Netbox Operator that we did with just to have the resources from Netbox as Kubernetes resources. All right, so we've been working on this for 1-2 years now. We've given multiple talks, so if you're interested in more specific topics, for example, just there's one about the Netbox Operator at the top, and on the right top you have one we just gave, I mean, just at the team or other teams also at Swisscom, about SDC. So if you want to know how we configure, how you can configure switches and routers also using SDC, KRM based, you can have a look at this talk. So with this QR code there, you can see all our past talks and also the slides and recordings to it. Yeah, with this, I think we're already at an end. I think there was a thanks there or questions, but that one left. So thanks for listening to us. And if there's any questions, we're open to take them now.
If you have any questions, just raise your hands and we will get the mic delivered.
Thank you. What is the capability level of your operators?
I don't understand. What do you mean with capability level?
Autopilot, upgrades, lifecycle, deep insight.
How do you have a level of capabilities of operators? I think you mean that. No? Yes.
I don't understand the question.
When you update your operator,
Can you?
how do you update the operator? How the operator manage the life cycle of itself?
It's a normal application, let's say, that we deploy in our cluster when there is new features. So in our case, for example, we have a weekly upgrade of the version when we introduce new features, and we just deploy it normally. You use flags for that, but nothing fancy there.
Okay.
So we didn't have any CR migrations to do yet. Let's see when that's going to come up. So at the moment, it's just pod, and we have a weekly release cycle where we just always have the usual dev, staging, prod.
And if you update your operator, for example, in the custom definition, I add a field, anything. Your operator is able to update all the resources created with this field?
Yes.
Yes. Okay.
I mean, with this field, let's say, the operator will never write the specs, or like it writes the specs of the ones below, but like not of the one on top. But so yeah, it will update. I mean, it will, as soon as you deploy it, it will reconcile all the resources. And of course, we need to think if we add a field or if we change something, we need to think about the logic. But the nice thing is, since we write them, since it's an operator and you're really flexible, you can do everything yourself. So we can have one version which then mutates this in all the CRs, and then the next version you can remove that code again. So it's flexibility.
Thank you.
Any other questions?
Yeah.
So we have 2 more minutes for questions. Then we will pass to the next speaker. But our speakers will be still available.
Yeah, I'll be quick. So my question is, you mentioned you integrate your operators with like external resources. So in this case, Netbox or your router configurations. How do you handle drifts in the outputs in the API? For example, if somehow someone connects to Netbox and changes the objects, do you see that? Do you do drift detection?
So we don't do full drift detection because there's so many parameters. So for us, it's not possible to do full drift detection. We add nodes. Like often there's fields for nodes. So for example, in Netbox, we add a node. Hey, this has been auto-generated. This has been generated by Netbox Operator. Please only edit if you know what you're doing. And but we don't go. The idea is really that it comes from Kubernetes. I mean, basic drifts. If you edit fields. If you edit fields that are in our CRs, we overwrite them. Yeah. So we have a scheduled reconcile. We do that once a day at 10 a.m. The idea being that we know when it is, and usually during working time also. But with fields that we don't manage, we don't touch. So you can still, because they are, for example, as this connectivity as a service, I mean, they have hundreds of fields, and that's why we only expose the ones and use the ones that are needed, and those ones we overwrite, and those that you don't touch, we don't, like those that you don't define, we don't touch them.
Okay.
Yeah.
Right. Thank you.
Okay. Okay, the last question, and we are looking for a speaker to come to the stage. I mean, the next one.
Yeah, so I've seen some operators that goes away of like having a single custom resources with everything in it, and some others that split it by like business logic, different objects in their business logic. In your cases, it looks like you split it in different custom resources. Do you have some tips for this? Like, how do you draw the line of like this should be in the same custom resources? Is it like purely based on your business logic, or?
It's basically domain. Like we consider that the IPAM resources are into one operator. Then the network as a service, let's say, it will contact its own API. So we have kind of a domain separation for that. So
does it bring any issues, like consistencies, or when you start to having a lot of links between different custom resources? Is it problematic or not?
So that's one point. You need to make sure that if you have operators at the same level, that they are not dependent on each other. So the top one is only, like the bottom ones always depend on the top ones. So really need to make sure that the ones on the same level, they don't need resources on the, let's say,
Same layer.
horizontally.
Okay.
So that there we try to really be strict about that, so we don't have these issues of independencies and operators on the same level.
Okay, thank you.
Yeah, thanks, Pablo and Fabian.
Yeah, thank you.
Yeah, thanks for the presentation, and we will start the next one in a few minutes. This one?